All right, so one more video on decorators. This will be a quick one, and I believe it will be the last one unless I come back in the future and add something else, but for now it is the last one. And I'm actually not going to type code. This is actually code that I found online on Stack Overflow, and I thought it was a really good example to demonstrate the power of decorators. So what this does is it enforces types on whatever function we define. So it looks like this. It's called enforce. And I can pass in, a string and an int. And this basically guarantees that this needs to be a string and this needs to be an int. But not only that, it's also going to try to change this into a string if it's not, and change this into an int. So that's the more Pythonic way of doing things, is trying to kind of convert types and avoid problems if possible. If you can convert a float to an int and have it work, that's great, rather than freaking out that, hey, this float is not an int. The goal here for this decorator is to do just that. We specify whatever pattern we want, string, int, string, and then it's going to make sure that this is a string, and whatever we pass in, if it's not, it will be converted if it can. This needs to be an int. In this case, it's not, but it will be converted to an int, and then this will be a string, whatever the next thing is. Okay, so here's how it works. Up here, so we have enforce, and it takes an argument. So this is where we have to use the kind of nested functions, multiple nested functions. So we have the decorator. This is what's actually being returned on this line, this entire function. And inside, we have this function called newfunc. There's a note here. It just mentions that args is not mutable. If you don't remember that, it's not. It's a tuple. So we're going to just make something called newArgs. That's a list for now. And this is not necessarily the most efficient or the best implementation of this, but I think it's pretty nice and simple. Then all we do is zip together args and types. So that would look something like this. With this example, this is types right here. It's what we pass in to the decorator. And this here is args, what we pass into the decorated function. So when we zip them together, it would be something like hello, comma, string, and then the next one would be, what else was there? String 3, comma, int. Okay, so we're zipping these two things together, or however many are in there. And then for each pair in that result, what we're going to do is append to newArgs. So newArgs is an empty list. We're going to try and cast each argument with the type. So that means trying to cast hello as a string, which works, and we get hello. Then the next one, we try and cast 3, the string, as an int, which also works and gives us the integer string. Does that make sense, what's happening? So we're pairing them up based off of the types that are specified here, and then the actual arguments that were passed in. We're pairing them up, and then we're just casting each one no matter what. We could add a check in there to see, hey, is hello already a string? Then don't try and make it a string. But instead, this is just the simple version for demo purposes. Okay, then we just return f, which is whatever function we passed in, but instead we're calling it with newArgs, which is this. So we passed this in, whereas the input was this. So we went from this to that with this enforce. Okay, and if we test it out, my little demo function here, repeat message, all that it does is loop through a number of times you specify and then print a message that many times. So I could do print hello 5 times. And if we run it, we get hello 5 times. That's nothing special. But if this is a string now and we try it, it still works, even though without this enforce, we would have a big problem because it tries to loop 5 string times, which is a problem in the range. The range does not like a string. Okay, and as another quick demo, we could do something like divide, and it just takes 2 numbers, A and B, and all that it does is return A divided by B. And all that we want to check, if we do an enforce, is that both are, we could just say float, all right? Because if we have an int, we can convert that to a float without losing data. We could have said int on both of them, but then if we passed in a float, we would lose some data on it because it just chops off the end. So instead, let's call both floats. They both have to be a float. And now if I tried to call divide, I guess let me print a divided by b so it's clearer. Like this, we could divide, and if just test it out, 1 and 2 should work. And it does. But now, and those are both ints, by the way, and we're forcing them to be floats, and that works fine. But if I do 1, 4, both strings, still works. We get a float. So it converts them to floats. Okay, so hopefully you think that's kind of cool. If not, well, I guess it is not that cool. If you have any questions on how it works, I highly recommend you just post a question in the discussion board. This kind of stuff gets very difficult to walk through on your own sometimes, and you start to question how things work when you have all these nested functions and 3 returns, and I get it. It gets crazy. So if you have questions, post them. And otherwise, we're done with decorators for now.